We're on slide 24. For any real numbers A and B, so A and B are real numbers, not imaginary like on my shirt, only one of the following can be true. A is going to be greater than B, or A is going to be less than B. Or you can have or equal to. But you can't be both greater than and less than. So it's going to be one or the other. It's either going to be greater than or it's going to be less than. It'll either be greater than or equal to, or it'll be less than or equal to. It cannot be both greater than and less than. Not in real numbers anyway. Okay, the addition property of inequality, basically it just says if I add the same number to both sides, that the truth does not change, so the inequality does not change. And I'll give this to you with real numbers, so it's very obvious. 4 is less than 10, right? Okay. So if I add 3 to both sides, I get 7 and 13. 7 is still less than 13. So still true. And if I had 9 is greater than negative 2. If I add 4 to both sides, I get 13 and positive 2, it's still greater than. So I can add the same thing to both sides and the truth of the statement does not change. The same is true for subtraction. I can subtract the same number from both sides. Okay, so if 5 is less than 17 and I subtract 3 from both sides, 2 is less than 14. That's still true. And it'll be the same with greater than. Well, these two properties of addition and subtraction to solve single-step inequalities. If x plus 4 is greater than 6, I can subtract 4 from both sides the same way I would solve an equation. And nothing changed. Well, the numbers changed, but the inequality did not change. So x is going to be greater than 2. So if x plus 4 is greater than 6, x is greater than 2. That means that x could be 2.000001, and then everything else on to infinity. X can be any number that's bigger than 2. Y minus 12 is less than 10, so if I add 12 to both sides, that means y is less than 22. So y could be 21.9, and anything less than that, all the negative numbers on into negative infinity. So y would be greater than negative 4 here. With addition and subtraction, you can add and subtract anything, and it doesn't change that inequality symbol. But with multiplication and division, if you multiply both sides by a positive number, the inequality stays the same. But if you multiply both sides by a negative number, it does not. Okay, so as an example of that, again, I'm going to use real numbers so it's very obvious. If 3 is less than 10, you guys all agree 3 is less than 10? Okay. And if I were to multiply both sides by -2, this becomes -6 and -20. -20 is not greater than -6, or -6 is not less than -20. What happens there, I then have to flip my inequality. Because when you multiply by negative, you're actually moving to the other side of the number line. So if you were on the positive side of the number line, you're now on the negative side. It's flipping things around. Whereas if I multiply by a positive number, that's not the case. If I have 3 is less than 10 and I multiply by a +2, I have 6 and I have 20. Well, 6 is less than 20, +20. So if you multiply by negative, you have to flip your inequality around. If we divide by a positive, thank you, the inequality stays the same. But if you divide by a negative, you have to flip. Okay. And so if I used 15 is greater than -5. If I divide both sides by a +5, I have 3 and -1. 3 is still greater than -1. I divided by a positive, it didn't change. But if I divide both sides by -5, I now have -3 and +1. 1 is greater than -3. So it had to change, it flipped. Alrighty, so if I'm solving this inequality, I've got x divided by 6 is greater than or equal to 3. So I'm multiplying both sides by 6. My 6 is positive, so x is going to be greater than or equal to 18. 4x is less than 12, so that's 4 times x, so I'll divide by 4. I'm dividing by a positive, so the inequality stays the same, so x would be less than 3. Here I have -5x is greater than 20, so I have to divide by a negative. And since I divided by a negative, I'm flipping that inequality. So I just kind of do that as, like, you know, a reminder to flip it. It's like doing a somersault in the middle of air. X divided by -8, so I'm going to multiply both sides by a negative. Since I multiplied by a negative, I'm going to be flipping, so it was less than, so now it becomes greater than or equal to. And again, just flipped it. Step 1, we want to multiply by this 6. So I'm going to multiply both sides by 6. And that is going to give me -24c is less than 5c plus 58. Then I'm going to subtract 5c to get it onto the same side as the -24c. And that is going to give me -29c is less than 58. And then I'm going to divide by negative 29, so I'm going to flip my inequality. So divide both sides by negative 29. So C is greater than negative 2. On my next problem, my first step, anytime you see parentheses with numbers that need to be multiplied, that's always your first step, distribute. So I'm going to distribute the negative 6 and the positive 2. Don't forget now when you're taking this negative 6, you have to distribute the negative both times. So this becomes positive 24v minus 18 is less than 20v plus 6. Yes?
I was always taught when I was back in school, when it's for the, you know how you wrote 24v minus 18 is less than blah blah. I was told to write 24v and then plus a negative.
That's fine too.
Is that all right?
Yeah, they're the same. After we've distributed, the next step is we want to move all of the variables to one side. And it doesn't matter if you move them to the right or the left. That's also a preference. I'm going to move them to the left because that's where I like them, but it doesn't really matter. So I get 4v minus 18 is less than 6. So then I'm going to move all of the numbers to the other side. So I'm going to add 18 to both sides. And I get 4v is less than 24. Okay, I guess I put an extra step here. And then I'm going to divide by 4. And v is less than 6. So I'm just going to do that now. When you graph a linear inequality like this, you graph it on a straight number line. That line is straight. Okay. 6.
I have a question.
Yes.
For the first question we did,
Uh-huh.
did you not have to multiply the 5 by 6?
Up here?
Yeah.
No. When I multiplied both sides by 6, this was 5c plus 58 divided by 6. So when I multiplied by 6, these two 6's canceled.
No, the 5. The 5c.
Up here. Yeah, no, because it got canceled out by this 6.
Oh, okay.
So once that 6 was gone, there was nothing to multiply to. Does that make sense?
Yeah, sorry, I was just looking at it.
Wrong? Or not wrong, but differently. So when you graph these, if you have these symbols, you graph with an open circle. These symbols, you have to color in the circle on the number. So we have less than 6, so I have an open circle on 6. And then everything less than 6 is this way. So you just shade that side of the number line. And it really does not have to be pretty, just so long as I know that this is the side that's shaded. You don't even have to put all of the little number marks if you don't want to, as long as you have a 0 on there. So I have a reference place. And you put the 6 on the correct side of the 0, and then you shade the right direction, you're good. Okay? Compound inequalities use and, or. A compound inequality is like a compound sentence. It's two inequalities joined together. So it's two inequalities joined together. Okay. Intersections are ands. And the graphs overlap, and you only keep the overlapped part. Because if you think of an intersection of a road, the only part that's the intersection is the part where the two roads are crossing. So if I have x is greater than 4 and x is less than -3. Well, x is greater than 4 would be the overlapping portion. I put these backwards. I'm sorry. This was supposed to be x is less than 4 and x is greater than or equal to -3. So if you could fix my typo for me. So if I graph x is less than 4, just that part, I have an open circle on 4, and I'm graphing this part right here. And if I'm just graphing x is greater than or equal to -3, I have a closed circle on -3, and that would be all of this, the greater than part. Now when I do a compound, oh yes I do, thank you. When I do a compound inequality and it's an intersection, so it's an and, I'm only graphing the overlapping portions. So if we were to draw the only part that's going to overlap that the two graphs have in common is this part in between. So I go my open circle at 4, my closed circle at -3. And then 4 graphs this way, -3 graphs this way, so that tells me to graph in between. And this is the compound inequality. This is the only part that you keep. Where the ands can literally have intersections, can literally have the word and. You can have two separate inequalities and the word and, just like if you had a compound sentence. They can also look like this. This doesn't say the word and, but if you have a string connected together with two inequality symbols, this is an and as well. So this is also an intersection. There are two ways to solve this. You can either keep it together the way it is, or you can split it into two inequalities. And it's a matter of preference, you'll get the same answer. So if we keep it together, when you solve a regular equation, you have to do the same thing to both sides of the equal sign or both sides of the inequality. When you're solving a compound inequality that's an intersection presented this way, you actually have 3 sides. You have the right, the left, and the middle. So anything you do to 1, you have to do to 3 instead of just 2. Does that make sense? So I'm going to add 7 to get rid of that, but instead of adding it to 2 sides, I'm adding it to 3. So this would give me 15 is less than or equal to 3y is less than 30. And then I'll divide by 3. And again, I do that to 3 places instead of 2. And I get 5 is less than or equal to y is less than 10. The nice thing about the intersections done in this method is that when you go to graph them, it tells you that the y is in between 5 and 10, so that tells you where to shade. It's built in. You shade the part where the y is, and that's in the middle. So that's kind of nice. So 0, 5, 10. less than or equal to, less than, and the y is what's in the middle. If you don't like this though, if that's too visually icky, you can split it, and what you do is I have 8 is less than or equal to 3y minus 7, and then I have 3y minus 7 is less than 23. I take that middle part and I just write it twice. And it's an and. So you solve two separate equations. So I've got 5 is less than or equal to y. And if you ever want to rewrite that, you just flip it, but always make sure that the arrow is pointing to the same thing that it was already pointing to. So if your variable is on the left and you don't like that, you can, or on the right and you don't like that, you can turn it around. Just make sure you turn the arrow with it. And then I solve this one. And I get the same answer. Y is going to be greater than or equal to 5 and less than or equal to 10. Here, y greater than 5, y less than 10. Same answer. It's just a matter of preference as to which one you like better. So on this next one, I'll just solve with method 1. I guess I don't really need to rewrite it, but I'm going to anyway. So I'm going to subtract 8 from all sides. And hey, just for giggles, let's change this to a negative so you know what to do. This negative 4. Or, well, it was a positive 4. Let's make it a negative 4. So this will become negative 20 is less than negative 4x is less than or equal to 32 minus 8, so 24. And now I'm going to divide by negative 4, and I'm going to do that in all 3 places. And when I divide by negatives, I have to flip my inequalities. And I have to flip both of them, yes. So if you end up with an intersection that's a compound intersection like this that's all put together, and then you have to divide or multiply by a negative, you have to flip both of the inequalities. And then to graph this, I have 0. Negative 6 is somewhere over here. Positive 5 is somewhere over here. We're greater than or equal to with the negative 6. And we're less than with the 5. And it's an intersection, so I'm shading in between. Ors are called unions. And in the real world, a union is when you bring two things and you combine them together. A marriage is a union, 2 lives coming together. Our country is a union, 50 states coming together to make one thing. So unions, you keep all portions of both graphs. Okay, if I have x is greater than 5, 5 is here, and greater is all of this over this way. Forever in perpetuality. And if I have x is less than 3, 3 is over here, and less than is everything this way. Actually, let's make that negative 3. Okay, never mind, we'll keep it. I was just going to say it had more space, but that's fine. And if I have an or, I'm keeping both of all graphs. So I'm keeping the part that's greater than 5, and I'm keeping the part that's less than 3. So I actually just combine the two graphs into one graph. So the only part that's not shaded is between 3 and 5. So this is basically almost every number.
Except for 4. 4's all.
Well, 4 and then all the fractions and decimals between 3 and 5. Ands can be presented with the word and or as this compound situation. There's no compound situation with an or. It always has to say the word or. So what you'll do is you'll solve each inequality separately. And then you'll graph them on the same number line. Right. So in this case, I'm going to subtract 6 from both sides, and I get k is less than -10. And then here I divide by 3 on both sides, and I get k is greater than 4. And I go to my number line, there's 0, there's -10, there's 4. Less than 10 is everything this way. Greater than 4 is everything that way. So I'm going to graph all of this and all of that. On my next example, I'm dividing by -5, and let's not forget our negative. Remember that when we divide by negative, it switches. And then I'm going to divide by 3. And j is going to be less than or equal to -7. So I have a 0, -3, -7.
So you just solve them separately?
You just solve them separately, and then you graph them on the same number line. Now what can happen is you could get something like j, or let's not use j, let's use x. X is greater than 2, x is less than 5. Greater than 2, less than 5. So greater than 2 is all this direction. Less than 5 is all this direction. And you graph the whole number line. So when that happens, it's all real numbers.
You don't need to have them.
Well, I did have the circles that were open, but when I shaded, it covered them up.
Like on a test, would you want us to?
You know, because you're going to cover them up anyway. So if this happens that when you have an or, don't forget the word or. When you have an or and the overlap, they actually overlap as opposed to pointing opposite directions. When ors actually overlap, you end up with the whole number line. So you get every single number makes this true. Our good old friend absolute value. Now you'll remember, so just like a little note, that when we had the absolute value of x is equal to 3, that meant x equals 3 or -3. Do you remember that? With the inequalities, you split. And when you make the answer, well, when you change the sign of the answer, it's not really the answer, but I'll just call it that, you flip the inequality. So what I have is if the absolute value of x is less than 3, x is less than 3, x is greater than -3. So I changed to the -3, I flipped my inequality. So when I graph that, greater than -3 less than 3, I have an overlap, I have an intersection. Less than and less than or equal to in absolute value are the same as and. Okay. So these will give you intersections. If the absolute value of x is greater than 5, that means x is greater than 5, x is less than negative 5. So less than negative 5 is this way, greater than 5 is that way. So greater than or equal to, those are unions, so they're ors. This is intersection. This is a union. I'm just going to do like a little side note. If we had the absolute value of x equals negative 2, I had no solution, right? It's a little different with absolute value and an inequality of a negative. Absolute value less than negative 3, no solution. Absolute value cannot be less than a negative because absolute value is always positive. However, absolute value greater than a negative, this is true because absolute value is positive, so it's always greater than a negative. So these are solvable. So if you see less than negative, no solution. If you see greater than negative, then you continue to solve it. So then I get u is greater than negative 2, u is less than positive 2. Now, if we recall, greater than is a union. So when I graph this, greater than negative 2 is this way, less than 2 is that way. This whole thing will shade, and this whole thing will shade. So anytime you have absolute value of anything greater than a negative, your answer is going to be all real numbers. Because it won't matter what I put in there, absolute value is always positive. So it will always be greater than a negative. It doesn't matter what number I throw in there. So every number would work. Does that make sense? So you don't even have to do the solving. Absolute value less than a negative, no solution. Absolute value greater than a negative, all real numbers. Step 1, I'm going to do 6y minus 5 greater than 13, 6y minus 5 less than negative 13. This is a greater than, so it's an or. So it's a union. Solve each separately. So we split. Flip the inequality on the negative. And then solve each separately. So I'll add 5 to both sides here, giving me 6y is greater than 18. I'll divide by 6, giving me y is greater than 3. So that way. I'll come over on this one, add 5, giving me 6y is less than 8. Divide by 6. And I get y is less than 4/3. And 4/3 is a little over 1. And less than's that way. Yes. You're right. Thank you. Good catch. Get extra credit. So negative 4/3 is a little less than negative 1, so open circle and shade this way. And again, if you're not using an actual number line like this, you can put the 3 here and then, you know, a 0, and then you can just write negative 19 fifths.
Yeah, what if you don't know where negative 19 fifths is on the?
You know it's on the wrong, what side it's on of 0, right?
Yeah, no, I mean, I know it's a negative number, but it's all right if I just put 19.
Yeah, if you do it this way, this would be acceptable as long as you have the open circles and you're shaded here. And what I need is I need it on the right side of the 0. And then if they're on the same side of the 0, like if this was negative 19 fifths and negative 3, you'd need to know that the 19 fifths came to the which side of the 3. Does that make sense?